Ladies and gentlemen, greetings. My name is Handina Budiasyana and I'm from Pertamina University, Jakarta, Indonesia. On this occasion, allow me to deliver a presentation of our research with the title of Simulated Annealing Algorithm Performance on Two-Echelon Vehicle Reading Problem, Mapping Operation with Drones. Here are the outlines for today's presentation, starting with background, problem definition and formulation, computational study, and lastly, conclusion and future research directions. Indonesia is one of the countries with the highest disaster risk in the world, and one of the most common disasters that happens here is floods. Disaster mapping could be categorized as one of disaster management activities and can be done to respond to the disaster. This activity must be conducted in a relatively short time to obtain the latest information of post-disaster conditions. And one of the tools that can be utilized for disaster mapping is drone. The using of drones allows to increase efficiency, reduces disaster risk, as an early warning, monitors the occurred disaster, and able to reach the disaster-affected areas. However, drones have a limited flight range due to the maximum flight time. Depends on the types of the drones used. A research in 2017 shows that the use of the ground vehicles can increase the drone's coverage. So, to possibly reach the entire affected areas, we consider combination of ground vehicles with drones in this research. The problem was modeled as a 2-EVRP MOD with the first and the second echelon. The first echelon is to accommodate the ground vehicles as drone carriers, and the second echelon is where the drones assigned to the affected areas. Because the 2-EVRP MOD is derived from a 2-EVRP problem, therefore we can categorize it as an NP-hard problem. And we can use meta-heuristic algorithm to solve this problem. Here is the illustration of the 2-EVRP MOD. The ground vehicle travels on a road network near the affected area. When it reaches a certain point, we can call it a stopover point, the drone will fly to the target point here and collect some information regarding of the disaster and return to the stopover point before the battery runs out. The situation is depicted in a 2-echelon distribution network. The first echelon considers the ground vehicle traveled from a depot to the stopover point, and the second echelon considers the drone launched from the stopover point to the target point or the mapping points. We use simulated annealing here in our research and also determine the best parameters values to solve the problems. And the research object is the Bekasi city areas which were affected by flooding in February 2020. We also conducted parameter tuning for simulated annealing parameters. And here are the sets, parameters, and decision variables for the 2-EVRP MOD. For the formulation, we have objective function and constraints. The objective function is the time needed to minimize the time needed of the ground vehicle to transport the drones here, the drone's traveling time, and the mapping time done by the drones. The first and the second constraint is the limitation of the limitation, so that the stopping point of the first echelon can be visited only once. And the third constraint ensures the movement of the first echelon vehicles in seconds. The constraint number 4 and 5 ensure that the vehicles at the first echelon depart and return to the depot. Constraint number 6 and 7 denote the total mapping time at each stopover point. Constraint number 8 and 9 denote the total travel time of drone in the second echelon. Constraint number 10 denote the total travel time of the drone in the second echelon. Constraint number 11 and 12 validate the route for ground vehicles and drones. And constraint number 13 ensures that the drone flying and mapping time do not exceed its maximum capacity. Here is the brief explanation of the simulated annealing. Simulated annealing, or SA, is inspired by a slow cooling process on material, or commonly called by annealing, and it also adopts Boltzmann method and metropolis criteria in the process. Here are the data processing part. We also conducted exact method, and also we used a mathematical programming language, or AMPL, and the solver is Groby 9.0. The time needed to take the picture was 8.125 times 10 to the power of the negative 5 minutes per meter square. Point number 3 is the specification of the drones we used in our research. And the point number 5 is the specification of the laptop we used to did the research. For the parameter tuning process, we use the values on the table for initial temperature, final temperature, alpha, and a maximum iteration for the simulated annealing. 4 experiments was conducted for each SA parameters. The chosen parameter value is the one that produces the shortest average CPU time. So we focus on the CPU time only. And each data was ran 10 times to obtain the average objective value. And here is the illustration for a mapping area in instance 6. And the result, these are the simulated annealing parameter values here that generate the lowest average process time, and it's 0.4502. And here is the results between the AMPL and simulated annealing. And the objective value between the SA and the AMPL has gap around 4.28%. And we also used 3 neighborhood scenarios for simulated annealing, namely swap, reverse, and insert. The difference between AMPL and SA solution can be caused by, firstly, maybe the SA algorithm possibly trapped in the local optimum, and B, C# data processing being less accurate even there is no error detected. So the conclusion is the first one, exact method was conducted to obtain optimal solution, and meta heuristics was performed to find out the solution difference between 2 methods, and the result shows that there is a 4.28% difference between the objective value of AMPL or exact method and SA, or the meta heuristics we used in this research. And the idea of combining ground vehicles and drone in mapping operation for disaster can be considered by government to respond disaster in the future. For future research directions, we can conduct statistical analysis to analyze the difference between the solution obtained using AMPL and simulated annealing. And we can use different methods for neighborhood scenarios or initial solutions to obtain values that are closer with the optimal result. Thank you very much for your attention.